Hello guys, this is the Med Dude, and today we're doing Edexcel P2 IAL January 2022. So let's start. So we have question number 1. The table shows corresponding values of x and y for y equals 2 to the power of 5 minus root x. The table of values of y are given to 3 decimal places. So we have x 5.56, 6.57, y 6.792, 2.98, 5.858, 5.4, and so on. Using the trapezium rule with all the values of y in the given table, obtain an estimate for the integral with the limits 7 and 5 of the same function 2 to the power 5 minus root x. So what is the formula for the trapezium rule? The formula is, it's given in the formula booklet, it is as follows. So half height times by y0 plus yn plus 2 times y1 plus y2 plus all the way to yn. So that's the formula. So let's see if we can sub in any of the values we know, and also where height is b minus a, upper limit minus lower limit, all over n with strips. So let's work out if we can do this. So the first value is always y0, second value is y1, y2, y3, and y4. Now you can see the last value is what? It's y4, number 4, and over here the last value is yn. So we can say there n equals 4. Right? So now can we now work out what the height is? Yes, we can, because we know the limits is 7 and 5. So we can say 7 minus 5, and we know n is 4. So this gives us 2 over 4, which is 0.5, a half. Okay, so now what do? Now we substitute in the values. So the area of this integral, or the value for this integral, is half times 0.5 times, so y0, let's look at the values, 6.792. 6.792 plus yn, which is same as y4, 5.113, plus 2 times, so what are the other values that are remaining? These these three values. So 6.298, 6.298 plus 5.858, 5.858 plus 5.466. Close the bracket. Alright, so now let's put this in the calculator. So the outside we can see that it's half times a half, so that's a 0.25. Right? What else? Let's do this one first. So this will be what? 6.792 plus 5.113 in the calculator is 11.905. Now let's do this 2 multiplied by, let's put brackets in your calculator, 6.298 plus 5.858 plus 5.466, bracket close, and this gives us plus 35.244, and this is the brackets closed. Let's add the two values in the square brackets together. So we get 11.905 plus 35.244. This gives us 0.25 multiplied by 47.149. Now before we do this calculation, let's look at what else they're asking us. They're asking us for what? Giving your answer to do decimal places. So what should we do? We should have a rough answer to 3 decimal places, and then we round it. So let's see if we can get that. So 0.25 multiplied by 47.149 gives us 11.787. And this rounds to what? So now we can say a equals the integral of 2 to the power of 5 minus root x equals 11.79. So our final answer is 11.79. So what are the marks for this? So you get A1 for stating the answer, that's the 1 mark. Then we get 1 mark for using the formula of that's given in the booklet, A1 substitute M1 substituting the formula. Then for getting the height on its own, this is a standalone mark. This is B1. So even if you didn't work out A and you worked out H, you still get the marks. So that's the 3 marks. Now let's look at part BI. It says what? Using your answer to part A and making your method clear, estimate the integral 2 to the power 6. So it says 2 to the power 6 minus root x. Now, if you remember the exponent laws, so this is part BI. If we remember, we know we can write 2 cubed as what? We can write 2 cubed as 2 to the power 2 plus 1. And that's the same thing as saying what? 2 to the power 2, which is 2 squared, times 2 to the power 1. Right? Similarly, now we have what? We have 2 to the power 6 minus root x. Now we can write this as what? We can write this as 2 to the power 1 plus 5 minus root x. This gives us another 2 to the power 1 multiplied by 2 to the power 5 minus root x. So why have we done this? Because we know the value of this integral. We know the value or the approximated value of this integral, because we still have the same limits in the question. You can see same limits, so we still have the value of the same integral. So what should we do? Similarly, same thing. So the area of this integral, or the value 5, 7, is now we can write this as 2 multiplied by 2 to the power 5 minus root x dx, and we can just take the 2 out. This becomes 5 times 7, limits lower limit 5, upper limit 7, 2 to the power 5 minus root x dx. And we know the value of this. This is the same thing as what we've done in part A. So part A is, we know it's 11.79. So we can say 2 multiplied by 11.79. And this gives us a value of 23.58. So that's the answer for part BI. Now let's look at II. So II says what? Now this says what? It says 3 plus 2 to the power 5 minus root x. So this is what? 3 plus y, the integral of 3 plus y, where y we know is our f of x, right? Our function. So now to take this integral, all we have to do is a equals 5, 7, 3 plus y dx. All we got to do is separate them. This becomes 5, 7, 3 dx plus y. Y we know is 5, 7, 2 to the power 5 minus root x, which we know the value of. So this becomes what? What's the integral of 3? This is just 3x, isn't it? So we get 3x with the limits 7 and 5, plus we already know this value, which is what? 11.79. So all we got to do is add them, 11.79. And this gives us 3 times 7, take away 3 times 5, plus 11.79. So this gives us what? So we know that this is equal to 21 take away 15, which is equal to 6. So we just have to add 6 to 11.79, which we get is 17.79. So what are the marks for this question? So we get 1 mark for getting to the answer. 1 mark for getting to the answer, that's A1. And 1 mark for adding this integral into the integral value to 11.79. So that's our M1 mark. So this is our A1 for our answer. And for part I, same thing. For A1 for getting the answer, and M1 for understanding that we need to take 2 out as a factor. So that's our 4 marks. And that is the end of this question. Let's go on to question number 2. So curve C has the equation y equals 27x to the power half minus x to the power 3 over 2 minus 20. Find dy by dx, giving each term in its simplest form, and they tell you that x is greater than 0. So we can write this as what? We can write this as, so let's now rewrite the function. I'm going to rewrite it here just because it's convenient. So y equals 27x to the power half minus x 3 over 2 to the power 3 over 2 minus 20. Right? So what's happening here? How do we differentiate? We take the power down and then we subtract the power by 1. Similarly, we take the power down and we take away the power by 1. And we know if we can't differentiate a constant, this becomes 0. So we can write our dy by dx as dy over dx as a half multiplied by 27x to the power half minus 1 and then minus 3 over 2, 3 over 2, not 3 over 3, 3 over 2 multiplied by x to the power 3 over 2 minus 1, and that's it. Now let's simplify this, because they ask for what? They tell you that's simplest form. So this will only get you 1 mark. So this is 27 over 2. So a half take away a half, a half take away 1, yeah. A half take away 1 is x to the power of negative a half, then minus 3 over 2, x to the power, so 3 over 2 is 1.5, take away 1 is 0.5, which is a half. So this is our dy over dx. So we get 1 mark for differentiating properly. This is M1, and 1 mark for the answer, A1, and we can conclude that this is the final answer for A. Now let's look at part B. What does part B say? Then it says, hence find the coordinates of the stationary point. So how do we find the stationary points when we have a given curve and dy by dx? We know the stationary point is when the gradient function equals 0. Now the gradient function is also known as dy over dx equals 0. So what should we do? We should equate our part A answer to 0. So 0 equals 27 over 2. Now, let's make it into a form that might be easier to understand. So 2 root x, because it's minus x to the power minus half, minus 3 root x over 2. Now let's take this term to the other side. This becomes 3 root x over 2 equals 27 over 2 root x. Now we can multiply both sides by 2 root x to get rid of the 2 root x from the denominator. Then we can see that this cancels out, Then over here, the 2 cancels out with the other 2. You're left with 3 times root x equals 27. Now we know that root x times root x, it gives you what? It gives us just x. So 3x equals 27. And x equals 27 over 3, which is equal to 9. Now, are we done with the question here? Let's check. We have just found the x term. The question said, find the coordinates of the stationary point of C. Now, coordinates made up of what? X comma y. So now we need to find y. So what should we do? We need to substitute this value back into our y. So what do we get? So we know that our stationary point is what? It's 9 comma something. We don't know what that something is, so we're going to find that y equals 27 x to the power half, so 9 to the power half, then minus 9 to the power 3 over 2 minus 20. So let's now put this in the calculator. So 27 times root 9 is what? This gives us what? This gives us 27 minus, so let's put the calculator 27 times 9 to the power half minus 9 to the power 3 over 2 minus 20. This gives us what? Any clue? This gives us 34. When you put in the calculator, this gives us 34. I just checked it. 34. So are we done? Yes. 934 is the stationary point. So now we can put this here. This is stationary point. So what are the marks here? This is part B. What are the marks? So we get 1 mark for getting the x value. So we get 1 mark for getting the A1 for 9 and A1 for getting the y coordinate, y value. And then we get M1 for subbing it back into the equation. M1 for this step. And then we get 1 mark for finding x. So those are our 4 marks. Let's go to part C. Then it says, find d squared y over dx squared, which is the second differentiation, and hence determine the nature of the stationary point of C. So let's go to part C. Let's do part C over here. So let's see part C. Let's first write dy over dx, what dy over dx is. We know dy over dx is 27 over 2 x to the power of negative a half. Let's go back up to be sure. It's minus 3 over 2 x to the power of a half. All right. So to determine the nature of the stationary point, first we need to find d squared y over dx. We can do that. So we just have to differentiate it again. So same thing, bring the power down, take away 1, bring the power down, take away 1. So this becomes what? This becomes minus a half, 27 over 2, x to the power of minus a half minus 1, minus, or let's say plus a half goes down, minus 3 over 2, x to the power of a half minus 1. Now let's simplify this. So the minus stays where it is, the minus over here stays where it is, minus half times 27 over 2 is minus 27 over 4. X to the power of minus half, take away 1 is minus 3 over 2. Then we have half times negative 3 over 2, so that's minus 3 over 4. X to the power of a half minus 1, so that's what? Minus 3, no, that's a minus half. Minus a half, and that's it, right? Now we have got to the differentiation, right? Are we done here? No. Now we need to do what? We need to sub in our x value that we got for the stationary point, which is what? Which is, if we go back up, is x equals 9. So that's x equals 9, and depending on that we can determine it. So let's sub it in. That's minus 27 over 4 times by 9 to the power of minus 3 over 2 minus 3 over 4 times 9 to the power of minus a half. So now let's put this in the calculator. So we got minus 27 over 4, bracket open, 9, bracket close, to the power of minus 3 over 2 minus 3 over 4, bracket open, 9, bracket close, to the power of minus a half, gives us negative 1 over 2. Negative 1 over 2. Now what does this mean? We know that if d squared y over dx squared is less than 0, then it's what's the nature of the stationary point? It's a maximum. Similarly, if it was greater than 0, it will be minimum. So in this case, because it's less than 0, then we can say nature of this stationary point is maximum. Alright, so we have got there. Now let's see what we get the marks for. So we get 1 mark for, so this is our final statement because we got this. Our answer is, so we get 1 mark for writing A1, we got A1 for subbing in and concluding that it's less than 0. Then we get M1 for differentiating twice, and that's it, because it's 2 marks. So this is a lot of work for 2 marks, but these are 2 marks you can't afford to lose. So this is question number 2 done. Let's go to question number 3. So question number 3 says what? Find the first 4 terms in ascending powers of x of the binomial expansion of bracket 2 minus kx over 4 to the power 8, where k is a non-zero constant. Give each term in its simplest form. So if you go to the mathematical IAL booklet given to you in the exam, you will see that you'll see the formula given is a plus b to the power n, where it's a to the power n plus, over here you have n1, then it's a n minus 1, then it's b to the power of 1, right? And it goes and keeps on going. So let's say we do on the first 4 terms. That's n2, an to the power minus 2, b squared. Then we have so n3, an to the power minus 3 multiplied by b cubed. Alright, in this case, now let's figure out what are our a, n, and b values. Our a in this equation, or in this binomial expansion, is 2. Alright, what about our b? Our b is minus kx over 4. And what's our n? N equals 8. So now let's substitute it. So we get what? We get 2 to the power of 8. So that's fine. Plus 8, 1. And this is what? This is applying the formula NCR. This gives us This is the same thing as saying 8 factorial over 1 factorial and 8 minus 1, which is 7 factorial, and this gives us 8. And then this is an to the power minus 1, so that's 2 to the power of 8 minus 1. So I'm going to write 8 minus 1. And what's our b? Minus kx plus 4 over 4. So now let's do the same thing. 8, 2. Then it's to the power of 2 to the power of 8. Take away 2. Minus kx over 4 squared. Plus 8, 3. 2 to the power of 8 minus 3. Multiplied by, let's move this over here, multiplied by minus kx over 4 cubed. Alright, now let's work this out. So this gives us, so 2 to the power 8 in the calculator gives us 256. And then 8c1 is 8. 2 to the power of 8 minus 1, which is 7, gives us 128. Multiplied by minus kx over 4. Now what about 8, 2? That's the same thing. Let's try it. So 8 factorial all over 2 factorial, and then that's 8 minus 2, which is what? Which is 6 factorial. So 8 factorial over 2 factorial multiplied by 6 factorial gives us 28. Now let's work it out for 8, 3 as well, so we don't have to do it again. So that's 8 factorial over 3 factorial multiplied by 8 minus 3 factorial, which is 5 factorial. 5 factorial. So that gives us 56. So now let's see what we can do. So now we're on the third term. So that's 28 multiplied by 2 to the power of 8 minus 2. So that's 2 to the power of 6. So we're dividing 128 by 2 again. So that's 64. And that's what? Let's already square this value. This will be k squared, x squared, all over 4 squared, which is 16. Then plus 56. Then we have 2 to the power of 8 minus 3, which is 2 to the power of 5. Or we divide this value by 2, which gives us 32. And same, so minus k cubed will be a minus again. So minus k cubed, x cubed. 4 times 4 is 16. Multiplied by 4 again is 64. So now, all we got to do is write down the last formula. Write down the simplified expression. So 256 plus, so 8 multiplied by 128 multiplied by minus 1 over 4, and the calculator gives us what? It's not a plus, it's negative. So negative 256 kx. Okay, so now what about the third term? So it's 28 multiplied by 64 multiplied by 1 over 16, or k squared over 16. This gives us 112 k squared x squared. Then we have 56 multiplied by 32 multiplied by minus k cubed over 64. This gives us what? This gives us minus 28, which is 28 k cubed x cubed. So is this simplified enough? Yes, it is, because we can't simplify it any further. So this is the simplified form. So this is the final answer. So what are the marks you get for this question? So you get standalone marks for just writing these two terms. So if you just find the first two terms, you at least get 1 mark. Then we get A1 for either of the second two terms, and A1 again for getting both of them. So what's the first marks then? The first mark is just applying the formula. All you have to do is apply the formula, you get M1. So even if you don't know what to do, just writing the formula and subbing in the values will give you just 1 mark. Alright, let's go on to part B. Part B says what? So then we said they give us a function f of x equals 5 minus 3x multiplied by 2 minus kx over 4 to the power raised to the power 8 in the expansion of f of x. The constant term. So that's when 5 is multiplied by the constant here is 3 times the coefficient of x. So 3 times the coefficient of x. So I can write constant equals 3 times coefficient of x. Then it says find the value of k. So now using what we have just seen given to us, right? Let's write that down. So part B. So let's write first f of x equals what? Equals, so 5 minus 3x, so equals 5 minus 3x multiplied by the function, the binomial expansion 2 minus kx over 4 raised to the power 8. This is approximately what? This is 5 minus 3x multiplied by what we have, the expansion. So 256 minus 256 kx plus 112 k squared x squared, and we go on. Last term. What are they interested in? They told you the constant term. So now let's work out the constant term. This is when we have non-x values. So this multiplied by this. 5 multiplied by 256. This is the only constant term, correct? So our constant term is 5 multiplied by 256. And this is equal to what? This is equal to 3 times the coefficient of x. So we have to have a 3 here, bracket, coefficient of x. So now let's look at the coefficient of x. So that's when what? When you have a non-x number, constant multiply an x term, right? So that's when 5 is multiplied by minus 256 and minus 3x is multiplied by 256. You can see that 112, we don't care about it because we're only talking about the coefficient of x. And you can see that we don't care about k cubed, x cubed either because we're not talking about it. So how do we get the coefficient of x? That's minus 3. So it's a coefficient of x, so we don't need the x anymore, right? So minus 3 multiplied by 256, and it's plus 5 multiplied by minus 256k. And then we close this big bracket. All right, so now can we work this out? Yeah, we can. So 5 times 256, this is what? This is 1280 on the calculator. Then what? Then we have 3 multiplied by, so minus 3 times 256 is minus 768. Then what? 5 multiplied by minus 256 we already got is also minus, so in this case minus 1280 minus 1280k, and this is what we get. So now let's multiply out the brackets. So 1280, 3 times minus 768 gives us a minus 2304. 3 times minus 1280k gives us minus 3840k. So now we need to rearrange to find k. So now let's bring this term to the other side. This becomes what? 3840k equals, so now we're going to bring this to this side. So minus 2304 take away minus 1280. This gives us what? This gives us negative 3584. So what's k? K equals minus 3584 all over 3840. This is a big number. Let's see if it simplifies. So minus, in the calculator, minus 3584 divided by 3840. This gives us negative 14 over 15. So what's our final answer? Minus 14 over 15. Alright, let's see how many marks this was. This was worth 3 marks. So this is a lot of work for just 3 marks, but we got the answer. Let's see what the marks are. So 1 mark is for getting the answer A1K itself. 1 mark is for remembering that we have to use this constant equals 3 times coefficient of x. So this is our M1 mark, method mark. And our first mark is when we get the constant term, or getting either one of these constant terms gives us M1. Alright. So this is the end of the question. This is the end of the question. Now we have question number 4. So using the laws of logarithms, solve the equation. We have log base 3, 32 minus 12x minus 2 log 3, 1 minus x plus 3. So what should we do here? Let's look at here. Let's look what we have here. So we have the same base here. We have the same base here. So same base. And we can see that 3 does not have the same base. Not same base. So what should we do? We know the property of logs that the log of a of the base a and a of a is just equal to 1. In this case, we're dealing with log base 3, so let's see. The log base 3 times 3 of 3 equals 1. Now, because we have 3 of those, so we can say 3 log 3 base 3. Now, I don't like having 3's over here. Let's put it to the power using the power law. So this becomes what? So this is just 3, by the way, equals log of base 3 of 3 raised to the power 3. So what's 3 times 3? 9. 9 times 3 is 27. So we have log base 3, 27. So now we can rewrite the equation, and we can also bring this power up to this 1 minus x fraction. Becomes log base 3, 32 minus 12x. As you can see, this is an expression of ax minus bc, where we can't simplify this any further because we have additional subtraction within the base of log base 3 of 32 minus 12x. It's an expression. If they're not multiplying one another, they're not dividing. So we can't simplify them using the exponent laws. So now we get log base 3, 1 minus x. So we raise the powers, it becomes squared. And now we know 3 can be written as log base 3 of 27, log of 3, 27, right? So now what? So now you can see that these two logs are being added. Logarithms are being added. So we can say log 3 base 3, 32 minus 12x equals, and we know when we add, we're actually multiplying them in within the expression. So within the bracket, so log base 3, this becomes so 27 multiplied by 1 minus x whole squared. So now you can see that we have the same base. So the expression inside must be equal to one another. So we can say 32 minus 12x equals 27, 1 minus x squared. Now we can say this, we know what we can do this separately. 1 minus x squared is 1 minus x, 1 minus x. This is when we multiply 1 by 1, 1 by negative x, minus x by 1, and minus x by x. This gives us 1 minus x minus another x plus x squared. So let's bring it with respect to the power. So x squared, we collate these terms. This becomes minus 2x. So minus 2x plus 1. So now what's happening here? So we have 32 minus 12x equals 27, x squared minus 2x plus 1. So now we have to multiply everything by 27. So 32 minus 12x equals 27x squared minus, so 27 times 2 is 54, 54x. So this is 54x plus 27. So plus 27. So now let's bring all these terms to this side. So this will be 0 equals. So 27x squared stays the same. So now we have minus 54x plus 12x. And this gives us what? So this gives us, so it's 12 take away 54, which is minus 42x. This is minus 42x. So 27 take away 32, that's a difference of 5, so negative 5. So this we have 27 x squared minus 42x minus 5. So from here we can do three methods. You can either use the quadratic formula. We can use completing the square, or we can use calculator to give us the value, or we can factorize it. In that case, 0 equals 3x minus 5, and this equals 9x plus 1. Now this gives us a value of, so if you use the calculator, you'll get the values directly. You'll get So you got 3x minus 5 equals 0. So you'll get x equals 5 over 3. And you'll get, or 9x plus 1 equals 0. X equals negative 1 over 9. Because we took the 1 to the other side and we divided by 9. So now, let's see if these values are both correct. Now the easiest way we can do this is we have this expression over here, 1 minus x. We know that log base 3, the number inside can never be negative. Can never be negative. Because we can't take the logarithm of a negative number. So we can say that 1 minus x expression has to be greater than 0. So in that case, 1, or rather x, has to be less than 1. Right? Less than 1. Now 5 over 3 is actually what? It's 1.6 recurring, isn't it? And that's greater than 1. So only value of x equals minus 1 over 9. Now have we satisfied the equation? Because what did they ask? They said solve. Solve for what variable? X. So we have done. So we're done with the questions. X equals minus 1 over 9. So now let's look at the answers. Let's look at the marking points. So 1 mark is for getting x equals minus 1 over 9. Then one of the marks is getting to this equation. So that is M1. Then 1 mark is to get one of the answers here, get either one or both of these values from the equation. That is our M1. So this is actually our A1 mark earlier, getting to the equation. A1. So that's 3. And then there's one standalone mark for getting this on its own, B1. So if you just worked out what log base 3 of how we can represent 3 in log form, then you got 1 mark, and 1 mark for using that to either simplify the logarithms. So M1 here. Those are our 5 marking points. It is to be noted that you could have also taken this log. So let me do this in another color. We could have also taken this log over here to the other side, and we would get log base 3, 32 minus 12x all over 1 minus x squared equals log 327. And you can see it still gives us the same equation. So no matter what you do, you will still get the same answers, whether you move the log to this side or you don't do anything to the logs, or we can just add them as we did over here. All right, let's move on to question number 5. So we have f of x equals 3x cubed plus ax squared plus bx minus 10. When f of x is divided by x minus 1, the remainder is k. So that means what? That means that f of 1 equals k. That's something we need to remember. Then we have what? When f of x is divided by x plus 1, the remainder is minus 10k. So f of negative 1 is equal to minus 10k, where k is a constant. Show that 11a plus 9b equals 83. So now all we gotta do is, let's just first find out what f of, so I'm going to do part A over here. So let's do f of 1 equals k. So that's what? So that's 3 multiplied by 1. So that's just 3. So this is also 1 squared, 1. So 1 squared is just 1. So that's plus a plus b minus 10. And this equals k. Let's simplify this even further. So we get a plus b. So 3 take away 10 is minus 7. This equals k. Now let's look at f of minus 1. So 3 times minus 1 cubed is 3 times negative 1, which is negative 3. So we have negative 3 over here. Then we have negative 1 squared. So that's just 1. So that's plus a. Then we have plus b times x, where x is now negative 1. So that's minus b. Then we have minus 10 on its own. And this is equal to negative 10k. So we can write the equation a minus b. So minus 3 minus 10 gives us minus 13 equals minus 10k. So now, because we know k from earlier, so look, we know k. So we can write a minus b minus 13 equals negative 10 a plus b minus 7. So now this becomes a minus b minus 13 equals minus 10a minus 10b plus 70. So now this 13 can go to this side, the left hand side to right hand side. So we will get a minus b equals negative 10a minus 10b plus 83. And now we can move these two terms to this side. Then we get 11a, so 10 minus 1 is plus 9b equals 83. So what are the marking points here? So we can say that m1 getting f of 1, that's m1, relating it to k. m1 using f of minus 1, that's our second term. And our last point is our proof, where we showed this part basically over here. That's our a1. All right, this is pretty straightforward. So now we have given that 3x minus 2 is a factor of 0. So this means what? This means that 3x minus 2 equals 0. So x equals 2 over 3. So f of this particular value gives us what? Equals 0. So this is what this means, by the way, what we just did over here. Because if it's a factor, then it means that it equals to 0. And that means the x value we get from this, when we put it into the function, we will get a 0 value. It will be equal to 0. So now let's look at this. Now we have this equal to 0. Now we can sub it back into this, our original f of x, and see if we can get somewhere. So let's see. So f of 2 over 3 equals what? So this is 3 multiplied by 2 over 3 cubed plus a 2 over 3 squared, because you can see it's ax squared plus bx, so plus b times 2 over 3 minus 10. And this equals what? This equals 0. So let's now simplify. So 3 times 2 cubed over 3 cubed, this gives us 8 over 9. So we got 2 squared, which is 4, over 3 squared, which is 9. So we get 4a over 9. Then we get plus 2b over 3. Take away 10 equals 0. I don't like that we have a factor of negative. We have a denominator of 9. So let's not times everything by 9. So we get 8 plus 4a. So 2b over 3 multiplied by 9 will give us 9 over 3, which is 6. 9 over 3, which is 2, multiplied by 2, which is 9 over 3, which is 3, multiplied by 2, which is 6. So 6b minus 90 equals 0. So we get 40 plus 6b. Now let's move the 90 to the other side, and also 8 to the other side. This becomes 90 take away 8, which is what? It's 82. So that's our one of the equations. Our second equation we have already. This is not 40, this is 4a. 4a. So our second equation becomes what we were given with. Let me clear that up. We were given with, it was 11a plus 9b. So 11a plus 9b. And this equals what? This equals 83. Now we can either make b is the same, the coefficient of b is the same, or the a is the same. Now I'll just go with the a, so we have to multiply this by 11, multiply the second equation by 4. So this gives us what? This gives us, so 44a plus, so 6 times 11 is 66b. So 82 times 11 is, in the calculator, 902. So 11 times 4 is 44a plus what? 9 times 4 is 36, 36b. So 83 times 4 is 332. Now we take the difference between the two. So 66 take away 36 is the difference 30b. 902 take away 332, that's 570. b now equals 570 divided by 30. You can see 0, 0 cancels. 57 over 3 is 19. So we know b equals 19. Now let's sub it to the easier equation, which is the first one. So 4a plus 6 times 19 equals 82, right? So what's 6 times 19? 4a plus, so 6 times 19 is minus, or rather plus 114 equals 82. So 4a equals 82, take away 114. So 4a in the calculator equals 82 minus 114 is negative 32. So a equals negative 32 over 4. So this is equal to negative 8. So a equals 8. Negative 8, sorry, negative 8. So this is our final answer for A and B. So that's part B. Let's see what the marks are. So we get 1 mark for getting these two values, A1. We get 1 mark for using simultaneous equations, 1 mark for this. And we get 1 mark for subbing in f of 2 of 3. So 1 mark for this entire piece of working out, which is M1, where we had to sub in f of 2 of 3, 2 over 3. Hence, find the quadratic expression g of x such that 3x minus 2 equals g of x. So what are they really saying? They're saying that f of x equals 3x minus 2 ax squared plus bx plus c. This is equal to, now let's go back to the original equation. So it's 3x cubed plus ax squared. So 3x cubed plus a, we know is what? A is negative 8. So let's cross that out. So that's 3x cubed minus 8x squared. Then it's what? It's b, you know, is plus bx, so 19x plus 19x. Then what? It's minus 10. Yes? So now what? So now these two equations are equal to one another, right? So now we can write that. So that's 3x minus 2 ax squared plus bx plus c. Now to save time, I'm just going to copy paste this and duplicate it over here. Alright, so we can see straight off the bat that the constant term is going to be minus 2c. So minus 2c is equal to negative 10. So c equals negative 10 over negative 2, which equals 5. Right, now let's do it another color. We know that 3x squared will be just 3x times ax squared. So this will be 3a equals 3. So a equals 3 over 3 equals to 1. Now the tricky one. So now we need to find what? We need to find, let's say we go with the coefficient of x squared. Now how do we get coefficient of x squared? That's minus 2a multiplied by 3x times b. This equals to negative 8. So I'll write that down. So that's 3b minus 2a equals negative 8. So can we do this? Do we know a? Yeah, we do know a. Look, we know a. So it's 3b minus 2 times 1 equals negative 8. So 3b plus equals minus 8 plus 2, which is minus 6. So b equals minus 6 divided by 3, which is minus 2. So we have the values. So now we have g of x equals, a is 1, so x squared. B is minus 2x. C is plus 5. So we can now rewrite the equation as f of x equals 3x minus 2 x squared minus 2x plus 5. So that's our final answer. So this is our final answer. So the 2 marks are what? We get 1 mark for getting A, B, and C. So that's just 1 mark. And 1 mark for writing it down over here as a function. This is M1, sorry, this is the method marks. M1. So that's that. Let's move on to question number 6. So we have the points P. The points P are, so this is a circle, this is point P, 23, 4, 14, Q, 15, minus 30, and R lie on a circle as shown in figure 1. Show that angle PQR is 90 degrees. So they're saying this triangle here is a right angle triangle. So they're saying this angle is a right angle triangle. So the way we show this is we need to find the gradient of this line. So MQR or RQ, and we need to find PQ. And then we need to multiply each other and multiply them to each other, and they should equal -1, right? So they should equal -1. So let's try that. So I'll do part A here over here. So, or rather over here. So we have, so now we need to find M of RQ. That's what? That's the change of Y, right? So we know Q is -30 minus 14. Sorry, -30 minus 26. So that's -30 minus -26 all over 15 minus -9. This gives us, so that's the difference of 4 on the top, or -4 rather, all over 15 minus -9, which is 22. This is equal to -2 over 11. Then we have M of PQ. So this is what? This is, let's look at the coordinate of P and Q. And now let's take 14, take away -30, all over 23, take away 15. This gives us, so 14, sorry, this is just 14 plus 30, which is just 44, over 8. 23 minus 15 is 8. This gives us 11 over 2. Now we multiply them, MPQ multiplied by MRQ. This equals 11 over 2 multiplied by -2 over 11. So you can see we get what? -1, right? That's what we get. So this is, so 1 mark for calculating the gradients, so M1, and 1 mark for showing the proof of it equals to -1. All right, now it says what? Hence or otherwise, find the center of the circle and the radius of this of the circle C. Now we know that P to R, because we have proved that it's a 90 degrees, that this line over here is the diameter, where the center is what? It's the midpoint. So I'll do part BI over here, BI. So the midpoint is what? It's the difference between P and R over 2. So that's what? That's going to be the coordinate 23 minus 7 over 2, and it's going to be 14 minus 26 over 2. So the coordinate of center, so 23 take away 7 over 2 is 16. 16 over 2 is 8. 14 take away -26 is a -12. -12 divided by 2 is -6. So this is the center. Now let's look at the radius. The radius will be what? It will be any distance. So let's say we take O to P. So now we know what O is, the center O. Let's take O to P. So this will be II. So this will just be the distance, right? So this will be OP. This will just be the distance between this coordinate that we found center and P. So how do you do it? It's the difference of the x coordinate squared plus the difference of y coordinate squared. So in this case, there will be 8 take away -23 squared, and it will be -6 minus 14 squared. So OP equals, so this is -15 squared, plus, so -6 minus 14 is -20 squared. So this gives us root of 225 plus 400. So that's the root of 625, and that gives us 25. So the radius is equal to 25. So you got 1 mark for the radius, 1 mark for using the formula for the radius, and 1 mark for, so this is A1, this is M1, and this is our A1 for the center. That's our 3 marks. Then it says what? Given that the point S lies on C such that the greatest distance QS, that said that the distance QS is the greatest, find an equation of the tangent. So remember, tangent means we're using the equation y minus y1 equals m bracket x minus x1. All right, let's go back up. So we need to find the gradient. We need to find the coordinate at S as well. So we need to find 2 things. We need to find coordinate at S. It's not S, so let me just do this. So this is, we need to find coordinate of S1, S at x1 and y1, and the gradient at S. So how should we do this? So let's go back up. So we know S coordinate, we know the Q coordinate, and it says over here the QS is greatest distance when it's the diameter. So it passes through what? Center. pass through the center. So let's draw a line. So if we draw a line here, so it's a line all the way here. So we're roughly talking about some S value here. All right. So how do we do this? So if we can find how we can go from Q to O, then we can find how we can go from O to our point S. So let's write that down. We know Q is minus 15, or not, it's rather 15. 15 negative 30. We know the center O is, the center of the circle O is 8 minus 6. For the X coordinate, what's happening? We're subtracting 7. What about the Y coordinate? We're minus 6 minus 30, that's plus 24. So S will be what? Same thing, right? S will be what? It will be 8 minus 7 minus 6 plus 24. So S is what? S is 1 minus 6 plus 24 is what? Is 18. All right, now we have found one of the things that we needed. Now we need M. How can we find M? We need to find the gradient of QS is equal to what? What can we do? Also, yeah, equal to what? So what should we do? Because they want the tangent of the equation, tangent of C at C at S. So they want the gradient of this, and we can only find it if we find MQS, and then we take the negative reciprocal of it. So let's first find MQS. So let's just take these two coordinates again. This will be what? So this will be what? This will be, so what's Q? Q is 15, right? So let's take rise over run. So it'll be minus 30, take away 18, x and y, and it'll be 15, take away minus 1. That will be minus 48 over, so 15 minus 1 is this 14. So M of the tangent will be minus 1 over MQS. So that's what, minus 1 over the reciprocal, minus 48 over 14. So this, the M tangent is the other way around, so it'll be 14 over 48. And because we know it's negative divided by negative, it'll be positive. So this is 7 over 24. So now all we gotta do is substitute all these values into m's. We know what the m is now. So y minus, so y minus y1, which is 18, equals 7 over 24, x minus 1. Now they also says they want it in the equation ax plus by plus c equals 0. So we can multiply 24 to the other side, becomes 24 y minus 18 equals 7x minus 1 multiplied by 7x minus 1. So this gives us 24y minus, so oh wait, no, did make a mistake here. No, x, y. Let's see, x and y. Yep, I think it's fine. Okay. So 24. So let me just double check. This is question number 6. And this is, yeah, this is fine. 24. So 24 multiplied by 18, or negative 18 rather, 24 times negative 18 is minus 432 equals 7x minus 7. Now let's bring everything to this side, becomes 7x minus 24y. So 432 minus 7 is 425, so 425 equals 0, and this is our final answer. So what are the marks? So we got 1 mark for getting this final equation, then we get 1 mark for getting the reciprocal of the tangent, so that's going to be this over here, m1, and we get 1 mark for getting s. We got 1 mark for getting s. So that is B1 standalone. All right, let's go to question number 7. So this says, in this question, you must show all your working out. Also, you're working out itself for minus 90 is less than x, which is less than 90 degrees, which is greater than minus 90. So let's start the question. So first of all, let's change the range. So we have 2x minus 15. So this will be, the range will now be minus 90 times 2 minus 15, x and 90 times 2 plus minus 15. So this is what? This is minus 180, take away 15. This, the new range is minus 195 x. So 180 take away 15 is 165 degrees. So now let's look at the question itself. It says 3 sine 2x minus 15 equals cos 2x plus minus 15. So some people will get confused and will think, okay, well, we need to use cos squared plus sine squared equals 1. No, we don't, because we can just divide both sides by cos 2x minus 15. Cos 2x minus 15. So part I, let's do that. So when we divide both sides by cos x, it becomes what? 3 tan 2x minus 15. And this, the other side doesn't become 0. It's not 0. It's not 0. It's what? 1. Because we divide something by itself, becomes 1. Alright, so now what? So tan 2x minus 15 equals 1 over 3. So 2x minus 15 equals tan inverse of 1 over 3. This gives us what? This gives us, so tan inverse 1 over 3 is 18.43. Alright, 18.43. So let's see if we can get any other solution. So if we draw the cast diagram, CAST, we know we have 18.43, that's the positive, 18.43. And let's see, well, the other positive will be over here. So we can either keep on going. So we add plus 180. This gives us 198.43. Is it in the range? No, it's not. It's not in the range. So we can't use this. Let's go backwards. So we go backwards. So it'll be what? It'll be so it'll be 18.43 take away 180. And this gives us minus 161.56. Is this in the range? Yep, this is in the range. So 2x, so let me change the color. So 2x minus 15 equals 18.43, comma, minus 161.56 degrees. So x equals, so we add 15 and we divide it by 2. So plus 15 divided by 2 minus 161.56. We add 15 and we divide by 2. So x equals what? So 18 point, and first let's see what they want. They want it in what? They want it to 1 decimal place. So we should always first get our answer to 2 decimal places and then round it. So when we get this to 2 decimal places, so 18.43 plus 15 over 2 on your calculator gives us what? Gives us 16 point something, and 16 point, let's see, so 18.43 plus 15 divided by 2, 16.715, so this is 16.7, and they wanted to what? 1 decimal place, so that's fine. And then the next one we get is minus 73.28, so this is minus 73.3. So we get A1 for one of the answers, A1 for both of the answers. Then we get M1 for getting to the answer using the cast method or the sine wave method, whichever one is M1 for getting to 1 over 3 tan x, and 1 mark for using methods to get the answer. Let's look at the next part. Next part says solve for 0 is, so this is in radian modes, it's in 2 pi. So radians, make sure your per hour is in radians. So we have 4 sine squared theta plus 8 cos theta. Now we use this equation, and because we want to get rid of the sine squared, this becomes sine squared theta equals 1 minus cos squared theta. So now we substitute it, becomes, so I becomes, so we can write 1 minus cosine squared theta plus 8 cosine theta equals 3. So that's what? That's 4 minus 4 cosine squared theta plus 8 cosine theta equals 3. Let's move everything to the other side. Becomes 4 cos squared theta minus 8 cos theta. So 3 take away 4 equals negative 1. So negative 1 equals 0. So now you can see this is a quadratic equation, right? Now we can use your calculator, but you should always show the step at least. Show the step at least. All right. So how do we do this? So we need to write cosine cos theta equals what? So minus b plus minus square root b squared minus 4ac over 2a. Now the values we will get need to be within minus 1. So theta and so whatever values we get need to be between minus 1 and 1, right? So minus 1, answer why? Because cosine functions, any sine or cosine function, only go up to, our graph only goes up to negative 1 and positive 1. So let's see. So cosine theta equals, so minus b is, so minus b will be 8 plus minus square root b squared, so that will be 8 squared. So minus 8 squared minus 4 times a, which is 4, times c, which is negative 1, all over 2a, which is 2 times 4. So this, what does this give us? This gives us, let's see, so this gives us 2 plus or minus root 5 over 2. Now we need to check which one is greater than 1, which one is less than 1. So 2 plus root 5 over 2 is what? This is 2.11, and it goes on. So this is greater than 1, so we can't use this. So we can use, the only value we can use is cosine theta equals 2 minus root 5 over 2. So theta equals cosine minus 1, 2 minus root 5 over 2. And this is in radians, don't forget. So theta equals, so we get 1.69. This is what we get. So now let's draw this cast diagram again, or if you remember the table, so it's CAST. 1.69 is where? 1.69 is over here. This is because pi over 2 is around 1.59. So this is 1.69. So our corresponding value will be here. And the way we can get this is 2 pi minus 1.69. So this is equal to 2 pi minus 1.69 is 4.59. So this is our final answer. All right. So now, what do we get the marks for? We get the marks for the same thing. We get M1 marks for reaching to this equation. We get falling marks for not using this value. We get M1 for this. That's 2 marks. And we get A1 for one of these values and another A1 if we get both of these values. All right, let's move on to question number 8. So metal post is repeatedly hit in order to drive it into the ground. Given that on the first hit the post is driven 100 millimeters into the ground. So what does this mean? 100 millimeter into the ground. Okay, so let's read on. So on the second hit the post is driven an additional 98. So look, additional. So we know that something's happening here. We're adding something or we're subtracting something. This is an arithmetic series. All right. So the first hit is what? First hit is always A. Then we're going from 96. Third hit we're going to additional 96. So from 100 to 98 we're minusing 2, subtracting 2. From 98 to 96 we're subtracting 2. So our difference is 2. That's good. So it says additional sequences subsequent hit form an arithmetic sequence. Oh, they tell us anyways. So show that the post is driven an additional 62 millimeters into the ground with the 20th hit. 20th hit is what? I'm going to do it here. 20th hit is what? This is part A. Is equal to A plus 19D. This is 100 plus 19 minus 2. And that is 100. Take away 38. This is equal to 62. This is our 1 mark for B1. This is our mark. This is B1. So find the total distance. This is also given to us in the formula booklet, or you can memorize the sum of n terms. But in this case, we're doing sum of 20 terms, which is usually n over 2, 2a plus n minus 1d. This is part B. I'm doing it over here. So this gives us So n over 2, n is 20, 20 over 2, and then it's 2a, which is 2 times 100, plus n minus 1, so 20, which is 20, take away 1, difference is negative 2. So now what do we get? Let's see. So this is 10 multiplied by 200, and then this is plus 19 multiplied by negative 2. So what do we get? We get 100 multiplied by 162. This gives us 1620 millimeters. So this is our final answer. So we get, this is our final answer. So this is one of the answers. So we get A1 for stating this. So A1 for stating this. And we get M1 for using the equation. All right. Given that each subsequent hit after the 20th hit, okay, the additional distances follow a geometric sequence with the common ratio R. Okay, so what are they really saying? So I'm going to do it over here. So see, they're saying the 20th hit is our first value, 21st, our A, 20, which is AR to the power 0. Our first hit is our common ratio R, so that's AR. Our 22nd hit, or on the 22nd hit, the post is driven an additional 60 meters into the ground. 22nd hit equals AR squared. So we know the value is 60. So now we can just substitute it 60 equals. So A we know is 20th hit, which we know is 62 from the previous question. 62 R squared. So R squared equals 60 over 62 equals 30 over 31. So R equals square root of 30 over 31. Now what is this? Square root of 30 over 31. This gives us, so they wanted to what? To 3 decimal places, so we're going to give them 4. So 0.9837. So R equals 0.984. This is the final answer. So we get M1 for working this out, for M1, and A1 for getting the answer. Now it says what? After a total of n hits, the post will have been driven more than 3 meters into the ground. Fine, showing all the steps and you're working the smallest possible value of n. Now, to understand this, 3 meters, we can't work with 3 meters, now can we? Because they're asking about totals now. There are 2 sets of sequences. There is the arithmetic sequence up till 20. Then we have another sequence that's geometric that's going on. That's going to continue till 3 meters. Right? So, part B, 3 meters is equal to what? 300 centimeters, which is equal to 3000 millimeters. So we want the value just above 3 meters, right? So we want the value that of the sum to be just, so sum of the first 20 terms, that's the arithmetic sequence. I'm gonna call, so the n, the sum, the total hits, I'm gonna call it, so that's the 20 terms of the arithmetic a plus n minus 1 d sequence, plus, now we don't know, let's call it x. This is for the geometric AR n minus 1 series. So S of x is greater than 300. So do we know these values? Yeah, we do. So let's try to work them out. So S of 20 we worked out was sum of the first 20 terms is 1620 millimeters. So 1620 millimeters plus sum of x equals 3000. Is greater than 3000. So what is this? This becomes sum of x, which is geometric sequence, becomes 1380. What's the sum of x? Sum of x over geometric sequence is what? A times 1 minus r to the power n over 1 minus r, right? So let's now substitute this back into here. So we get a 1 minus rn over 1 minus r is greater than, what's the value? 1380. 1380. Now a, do we know a? We know a is 62. We know 1 minus rn. Let's use r as root 30 over 31 to make our life easier. So root 30 over 31 to the power n all over 1 minus root 30 over 31 is 1380. So now we have to do what? We have to get rid of we have to find n, right? So now let's move this power let's move this into the other side, and let's say we divide by 62 as well. So what happens? So we get 1 minus root 30 over 31 to the power n equals 1380, 1 minus r, which is 30 over 31, all over 62. Now this is probably going to be a number, isn't it? Right? So before we do that, let's move this r to the other side. So this becomes 1 minus 1380, 1 minus square root 30 over 31 over 62 is greater than root 30 over 31 to the power n. So now let's work this out. So this is 1 minus 1380 bracket open, 1 minus root 30 over 31 bracket close, all over 62, or just that particular term over 62 gives us 0.638, and it keeps on going. So now let's does it keep on going? Yeah, it keeps on going. Let's stick with that. All right. So this is equal to root 30 over 31. And now we have to log both sides to get rid of the n somehow. So we get log of 0.638 is greater than log of root 30 over 31. And so n now goes down, becomes log of 0.638. And this is greater than n log root 30 over 31. So let's first check what type of value these are. If you put this in the calculator, you'll get this is a negative value. Now let's put this into the calculator. Log of root 30 over 31. This is also a negative value. So now we're going to divide by this value. So what's going to happen to this inequality sign? It's going to change. This becomes n. This becomes log 0.638. Don't round your values, obviously, in the calculation. So log of root 30 over 31. So now let's divide them. Let's divide them. So log of 0.638 and goes on decimal all over log of root 30 over 31. What do we get? We get that it's 27.4 is less than n. So what does n have to be? Or rather x in this case, but and small n equals 28 terms, right? 28. So what's our capital N? Capital N is equal to 20 plus x. We found this was x, right? The sum of a geometric sequence in that. This is now 28. This equals 48. So n equals 48 hits. So that's our final answer. So where are the marks here? So we get 1 mark for getting to n. We get 1 mark for dividing using this equation. So we get m1 for this. Then we get m1 for using the geometric sum formula, so m1, and substituting into the formula, and then remembering that they're split into 2 arithmetic and geometric sequences, so 2 sequences consisting of arithmetic and geometric. So this gives us m1. So 3 m1 marks and 1 last mark. So now let's move on to question number 8. So this says, the question number 9, this says what? This says that figure 2 shows the curve C with the equation y equals x minus x squared. So this is y equals x minus x squared. Let's label it y equals x minus x squared. Then we have the line L equals what? This is the line L with the equation y equals mx, where m is a constant between 0 and which is m is greater than 0, which is less than 1. All right, let's see. Then it says what? So I'm going to call this y equals mx. So let's do part A over here. What does it say? Part A says find, so the line and curve intersect at origin and at point P. So at point P, find in terms of m the coordinates of P. That's pretty simple. So all we have to do is equate y equals x minus x squared and y equals mx to find x coordinate and then the y coordinate. So mx equals x minus x squared. Let's bring all the x squared to the other side. Becomes x squared minus x plus mx. So now we can take x common, equals 0, so let's take x squared minus, or rather plus x m minus 1, same thing, right? Or yeah, same thing, m minus, give me a second, x minus x squared, and we take to the other side, x squared minus x, and minus x plus mx, we take minus 1 plus m minus, same thing, equals 0. So now we can take x again. This becomes what? X plus m minus 1 equals 0. So x plus m minus 1 equals 0. So x equals 1 minus m. So y equals mx. So this is m1 minus m. So coordinate of p is equal to 1 minus m, and y coordinate m1 minus m. So this is our part A. Our part A, so we got m1 for getting y equals 1 minus 1m. So m1 for reaching here, and we get another mark for reaching the x coordinate. So m, or rather a1. All right. So now what? For everyone, for getting both of those values, we get a1. So the region R is shown shaded in figure 2 is bounded by C and L. Region R1, so this is the curve, take away the line formula. So show that the area R1 is this. So let's do that. So this is what the area is. So let's look at the limits. It's 0, and the limits over at P, sorry, limit at P. So that's going to be 0, and the x coordinate of P, which we worked out, is 1 minus m. So 1 minus m. So we're going to do the line minus curve. So sorry, curve, take away the line. So this is going to be curve minus line dx, which is equal to 1 minus m. The curve is what? Is x minus x squared. The line is what? Minus mx dx. Right? Now, can we simplify anything before beginning our thing? Can we simplify anything? Yes, we can. Look. So x minus x squared minus mx can be simplified into what? We can have x on its own, 1 minus m minus x squared. Now this is a constant, so now let's put it in the front. So 1 minus m x minus x squared. So now let's redo this. So 0, 1 minus m, 1 minus m x minus x squared dx. Now this is a very normal integration problem, isn't it? This becomes what? X, when we integrate, it becomes what? X squared over 2, right? So now let's integrate it. This is what? This is 1 minus m x squared all over 2 minus x cubed all over 2 over 3 in this case, sorry, 3. That's it, right? That's our, and it's to the limits of 1 minus m to 0. So now we have the limits. I'll draw it here again. So 1 minus m x squared over 2 minus x cubed over 3 with the limits 1 minus m to 0. This gives us what? This gives us the 1 minus m times 1 minus m squared over 2 minus 1 minus m cubed over 3, and this is obviously taken by 0. So this equals, now that's just 1 minus m cubed over 2 on 1 minus m cubed over 3. If you treat it as 1 over 2, take away 1 over 3, you get what? You get 3 minus 2 over 6, which is 1 over 6. So this will be the same. This will be 1 minus m cubed over 6. So we have reached the final answer. So we have proved it. So what do we get? So we got 1 mark for getting here. Then we got 1 mark for using the limits. This is our m1 mark, or dependent m1 mark. Then we have to get to the integration process, which is curve minus line. That's our m1. So we have 1, 2, 3. We're missing 2 more marks. So we have one more to remember. The limit is for p, that is m1. And just one mark for remembering that it's curve minus line. And this mark is actually for collating the terms and making sure m is 1 minus m is reached there somehow. All right, let's look at part C. Part C says what? It says region R2 is also showed in the figure 2 is bounded by C. So yeah, this R2 over here. Okay, got it. So it says given that our area of R1 is equal to R2, find the exact value of m. So we know this value, we know this value, and we can work out the entire curve value. So what are they saying? They're saying part C. They're saying the area of the curve, right, this curve over here, is equal to area of R1 plus R2. Now we know that R1 equals R2, right? So the area of this is equal to 2R1, which we know is this, right? So this is equal to 2 times 1 minus m cubed over 6, which is equal to 1 minus m cubed over 3. Alright, so now let's work out the area of the curve. That's going to be 0. Now let's work out the limits. The limits here is what? It's x minus x squared equals 0, x1 minus x equals 0, so x equals 0 or x equals 1. So the limits are 0 and 1. So 0 and 1, x minus x squared dx. So now let's work this out. This will be x squared over 2 minus x cubed over 3 with the limits 1 and 0. So this will give us what? 1 over 2 minus 1 over 3 minus 0 equals 1 minus m cubed over 3. So we know this is what? 3 minus 2 over 6 again equals 1 minus m cubed over 3. This is a sixth. And this is now 1 minus m. Now this is now manipulation. This becomes, so 3 goes to the other side, becomes 3 over 6, that's a half, equals 1 minus m cubed. Now we can cube root both sides. This becomes 1 over cube root of 2, because cube root of 1 is just 1, equals 1 minus m. So m equals 1 minus 1 over cube root of 2. So this is our final answer for m. And what are the marks? So we get A1 for getting this answer over here. Then we get the dependent M mark for getting 1 over 6. Then we get 1 mark for remembering R1 plus R2. Then what? Then we have, yeah, that's it, 3 marks. That's it. Now let's move on to question number 10. This is the last question. Or is it? Let's check. Yeah, this is the last question. So this is what? Let's see. So we have prove by counterexample that the statement if p is a prime number, then 2p plus 1 is also a prime number, so is not true. So now it's proved by counterexample. Now let's take values. So if p equals 1, then 2, 1 plus 1 equals 3. That's still a prime number. Let's look 2. 2 times 2 plus 1 is 4 plus 1, which is 5. So it doesn't work. 3. 2 times 3 plus 1 is equal to 6 plus 7, which is still a prime number. Let's go 4. 2 times 4 is 8 plus 1 is 9. That is not a prime number. So we can say if p equals 4, then what? What's the full statement? We say then 2p plus 1 equals 9, which is not a prime number. A prime number. Alright, that's it. We use p equal 4, and that's the 1 mark. Now, then it says use of proof of exhaustion, prove that n is an integer, then 5n squared plus n plus 12 is always even. Now for these questions, you have to prove for n equals 2k for even cases, and n equals 2k plus 1 for odd cases. So we have to use both values and substitute them and show that they're still even. How can we show they're even? If they multiply by 2 anywhere at the end. That's how we show if it's even or not. So now let's use that. So So if n equals 2k, this is for even numbers. So we'll have 2k squared plus 2k plus 12. And this is what? 5. So 4k squared plus 2k plus 12, which is plus n, right? Yep. That's 20k squared plus 2k plus 12. and then we can take 2 out. So this becomes 10k squared plus k plus 6. So result is divisible, or rather has a factor of 2. Result has a factor of 2, so is even. Now for n equals 2k plus 1, odd number, not odd numbers, odd numbers, we will get, so it'll be 5 times 2k plus 1 squared plus 2k plus 1 plus 13. So now to make our life easier, first let's work this out. So this is 2k plus 1 times 2k plus 1, multiply them outside, and then 1 times both of them. This gives us 4k squared plus 2k plus 2k plus 1. This is equal to 4k squared plus 4k plus 1. This is now equal to, so 5 multiplied by 4k squared plus 4k plus 1 plus 2k. So 1 plus 12, sorry, this is 12, not 13. 1 plus 12. So this will be 13. Then we get 20k squared. So this becomes 20k plus another 2k. We're adding the plus 2k here. We're adding 2k separately. This is not in the brackets. 2k. So this becomes 22k plus 5 plus 13, which is 18. Then we can say that 2 goes into 10k squared plus 11k plus 9. So again, a factor of 2 is present. So what can we say? We can say the concluding statement is, so expression 5n squared plus n plus 12 is always even for all integers. Alright, that's the end of the video. Good luck for your exams, and I'll see you next time.